The rusty world is full of mystery and features some of the most severe geology in the solar system. Find out more about the smaller, colder neighbor of Earth. Long considered a bad omen in the night sky, Mars is the crimson planet named for the Roman god of war. The planet's rusty red surface also conveys a message of annihilation in its own unique way. The fourth planet from the Sun, which had liquid water on its surface and possibly even life, could have been mistaken for Earth's smaller twin millions of years ago. The world is currently a chilly, dry desert with few indications of liquid water. But after decades of investigation utilizing orbiters, landers, and rovers, researchers have discovered that Mars is a dynamic, wind-tossed landscape that might, just might, still host microbial life beneath its rusted surface. An extended year and changing seasons. Mars is the seventh largest planet in our solar system and roughly half the diameter of Earth, with a radius of 2,106 miles. 37.5% of Earth's gravity is present on the surface. The duration of a Martian day, known as a sol, short for solar day, is determined by the rate at which Mars revolves on its axis, which is every 24.6 hours on Earth. Because of its 25.2-degree tilt from the plane of its orbit around the Sun, Mars experiences seasons that are identical to those on Earth. Spring and summer are experienced by whichever hemisphere is slanted closer to the Sun, whereas fall and winter are experienced by the hemisphere tilted away. The equinoxes are two precise times each year when both hemispheres experience equal illumination. The seasons on Mars, however, are distinct from those on Earth for a number of reasons. For starters, Mars has an average orbital distance of 142 million miles, placing it approximately 50% farther from the Sun than Earth. Sense of this, Mars' year and season lengths are longer because it takes it longer to complete a single orbit. On Mars, a season can last up to 194 sols, or slightly more than 199 Earth days, while a year lasts 669.6 sols, or 687 Earth days. Since Mars' axis of rotation varies its tilt considerably more frequently than Earth's does, the Martian climate has fluctuated over periods of thousands to millions of years. Additionally, because Mars' orbit is less elliptical than Earth's, it experiences greater variations in orbital velocity throughout a Martian year. The solstices and equinoxes on the red planet are impacted by this yearly change. Summer and spring are longer in the northern hemisphere of Mars than fall and winter. Another issue is that Mars' atmosphere is far thinner than Earth's, which significantly reduces the amount of heat the planet can trap near its surface. On average, Mars' surface is minus 81 degrees Fahrenheit, which is 138 degrees colder than the average temperature on Earth. Surface temperatures on Mars can range from 70 degrees to minus 225 degrees Fahrenheit. Watery and windy once. The atmosphere of Mars, which is mostly composed of carbon dioxide, nitrogen, and argon, is the main factor influencing its geology today. The air is absurdly thin by Earth standards. Mount Everest's air pressure is roughly 50 times greater than the planet's surface. Despite the thin atmosphere, Martian breezes can reach speeds of up to 60 miles per hour, creating large dust storms and fields of foreign sand dunes in the process. But there was a time when the red planet was covered in both wind and water. Robotic rovers have discovered unmistakable proof that the surface of the red planet once supported lakes and rivers flowing with liquid water billions of years ago. This indicates that water was once liquid on Mars' surface because Mars' atmosphere was sufficiently warm and dense enough to maintain heat for a long period of time. Today, however, there are no significant bodies of liquid water on the surface of Mars, despite the fact that water ice is abundant beneath the planet's surface and in its polar ice caps. Additionally, Mars lacks a planetary magnetic field and an active plate tectonic system, which is the geologic engine that propels our active Earth. The absence of this shield makes it simpler for the high-energy particles from the Sun to peel away the atmosphere of the red planet, which may help to explain why Mars' atmosphere is currently so thin. But until 4.12 to 4.14 billion years ago, Mars appears to have had an internal dynamo that was responsible for the planet's magnetic field. What caused the Martian dynamo to stop? Researchers are still working to understand. Mars features mountains, valleys, and volcanoes, just like Earth and Venus, but those on the red planet are by far the largest and most dramatic. The tallest volcano in the solar system, Olympus Mons, rises to a height of around 16 miles above the Martian surface, which makes it 3 times higher than Everest. The average slope of Olympus Mons is only slightly steeper than a wheelchair ramp due to the volcano's 374-mile wide base. Because of its size, the peak follows the curvature of Mars' surface. You could see Olympus Mons summit if you were standing at the mountain's edge. The solar system's lowest lows can also be found on Mars, along with some of its highest highs. The famous canyon network of the red planet, Valles Marineris, is located southeast of Olympus Mons. The gorges extend for around 2,500 kilometers and can be up to 4.3 miles deep. The network of chasms is astonishingly 200 miles across at its widest point and is 4 times deeper and 5 times longer than Earth's Grand Canyon. Mariner 9, the first spacecraft to circle another planet when it landed on Mars in 1971, gave the valleys their name. 2 hemispheres in one story. Mars formed from the gaseous, dusty disk that encircled our young sun about 4.5 billion years ago. The interior of the red planet gradually divided into a core, a mantle, and an outer crust that is 40 miles thick on average. Like Earth's core, it is probably formed of iron and nickel, but it also likely includes more sulfur than ours does. The core is believed to be approximately 2,120 miles across, give or take 370 miles, but the exact dimensions are unknown. By monitoring how seismic waves travel through Mars, NASA's InSight lander hopes to shed light on its mysterious innards. Mars is unlike any other planet in the solar system in that its northern and southern hemispheres are so drastically different from one another. The crust of the planet can only be 19 miles deep in its northern hemisphere, which is primarily low-lying plains. However, the crust in the southern hemisphere's highlands can reach a thickness of 62 miles and is dotted with numerous extinct volcanoes. What took place? The discrepancy may have resulted from variations in internal magma flow patterns, but some scientists believe it to be the result of one or more significant impacts that Mars has experienced. According to a recent model, an object the size of the Moon collided with Mars close to its south pole, giving the planet its 2 faces. The planet's distinctive dust, which is colored in a variety of orange, red, and brown hues by iron rust, covers both hemispheres. Cosmic partners. The 2 tiny, amorphous moons Phobos and Deimos were added to the red planet at some point in the distant past. The 2 lumpy planets were found in 1877 and were given their names after the charioteers and sons of the Roman god Mars. It is still unknown how the moons were created. One theory holds that they originated in the asteroid belt and were drawn towards Mars' gravitational pull. Recent simulations, however, imply that they might have originated from the debris that Mars had thrown up after a significant impact long ago. Less than 10 miles in diameter, Deimos is the smaller of the 2 moons and orbits Mars every 30 hours. Phobos, its bigger twin, has several scars on its surface, including craters and deep grooves. What produced the grooves on Phobos is a subject of much discussion among scientists. Are they evidence that the Moon is being torn apart by Mars' gravity, or are they traces left by rocks sliding across the surface following an ancient impact? The Moon's future will be significantly less cool either way. The moon Phobos is expected to either collide with Mars' surface in approximately 50 million years or explode into smithereens as it approaches the red planet by around 6 feet every century. was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.